Hello and welcome! We are going to be learning all about fractions and percentages today. You will definitely want to have a computer so that you can open up Desmos and do these activities with us.
Indeed, I'm super excited, but let's give some shout outs. I see Serafina from North Carolina.
Hello to Arushi watching in Seattle, to Rosalie in Iowa, and to Aaliyah in Houston, Eli in Vermont.
Betty's Child.
Ruby from Kansas. I also see Gamerboy, Emraya, Gigi, and Arthur Gupta. Who else do we have? Hello to the Rosen family.
Excellent.
And I see several comments saying hi to Kaladin. Yes, Science Dog is back.
I only saw one comment. It disappeared before I could get it. I don't know if anyone solved Science Mom. There were 4 numbers we were supposed to be able to use to get the number 4. So here are the 2 that I came up with. So if we had, we had to use the numbers 6, 2, 7, and 4 once each. And in this case, 6, this is like 6 divided by 3 plus 2, or 2 plus 2. So that one works. And then I did 7 times 2 minus 4 minus 6. So 7 times 2 was 14. And then if you subtract 4 and then subtract 6 from that, you get 4.
Ooh, so those are good ways to go about it.
Yeah, so maybe there were other solutions, but I didn't find any myself. And yeah, it didn't seem like the chat found too many. So, tricky problem, especially when they only give you 2 minutes.
That was a good warm-up. Shout out to Seven. I saw their solution was the same as Math Dad's second one, and it looks like Silver Dragon has got one as well. So those little warm-ups do help to get your brain involved and just engaged. And now we're going to dive into our lesson. It'll be about 45 minutes, and we're going to have some hands-on practice for you to strengthen those brain muscles.
That's right. So this lesson comes out of the 7th grade curriculum, but it's a piggybacking on what we talked about last time, which was percents. So in particular, we have percentages and fractions and how they relate to each other. So let's recap what we did last time. And when we talked about percents, we used an analogy. And it's one that everyone is pretty familiar with, and that's dollars and cents.
That's right, because 100 pennies make $1, and so if you can think about percentages that way, that's a pretty helpful strategy sometimes.
That's right. So we would see numbers that were written something like 1.07. And usually there's a dollar sign in it when we're talking about money. So it's not the same as just having $1. It's $1 and 7/100ths of a dollar. So there are lots of different ways of writing that. I'm going to go ahead and remove the dollar sign, although if it helps you to visualize it, to pretend it's there, go ahead. But yeah, we found that this was the same as 1 plus 7 over 100.
That's right.
We talked about place value. So we had the ones place, we had the tenths place, and we had the hundredths place. And after the hundredths place came the thousandths place, and then the 10,000ths place. It turns out the numbers can go infinitely in either direction. There's no limit to how far out those digits can go. And yeah, so remember this money, so dollars and cents, when you're trying to think of hundredths. And in particular, last time we even had like a 10 by 10 grid. And what we found is that if it was 10 by 10, that meant there were 100 little squares. Each little tiny square was 1/100th, and then that acted like a penny.
That's right.
All right, so if you head over to the Desmos activity, the exact code is down in the description, then you will see a screen that looks like this for your warm-up. And just knowing what you know about percentages, which basically just means what fraction of 100 is there. And we have 3 different figures here. Figure A, figure B, and figure C. I'm going to see how we've managed to do so far. It looks like a good chunk of the class has not only attempted, but actually managed to get it right. And I'll give you another minute, because I want you to think about these. These are 3 separate questions, but in each figure, what percentage is shaded?
Good job, Arthur and Gibran and Rosalie. I see Arushi and Eli and Cora have all completed this. And just take a minute and do this warm-up.
Ooh, and we actually don't want to type the percent in because it's kind of built in. So if I wanted the answer to be 56%, I would just type 56. It turns out if you type a percent sign, then it tries to tack more on, but that box already had the percent built in. Ooh.
I'll give you just a few more seconds. It looks like most people have given this a try.
That's right.
Good job, McCall and Gamer Boy.
So when you look at this problem, Science Mom, does it look like a problem with pennies and dollars to you?
It doesn't. And let me count. How many segments do we have here in A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 segments. I don't have 100 segments.
Nope. But it's possible to chop a dollar into 10 equal pieces. And when we do, we call them
Dimes.
Yeah,
That's
dimes.
right.
Yep.
So if I had 2 dimes, that would be the same as how many pennies?
That would be the same as 20.
20
So that's what
pennies.
Emily says the answer is.
All right, help me out if you're watching live, or just say the answer out loud if you're watching the replay. How about B? That one's easy, right?
Yeah, so Silver Dragon AR is saying that you're basically counting by 25s when you're doing quarters. Sorry, that's for part C, but yeah, that's 50% is a half. And then, yeah, for part C.
That's right. Thinking about quarters really helps. And 75 cents is how many I have. So there we go.
That's right, so 75%. So anytime we're talking about a fraction, we can think of that as, yeah, a percentage. Just think of the numerator when divided by 100. And that's what your percentage is. Or 75 pennies out of a dollar if we were snipping up a dollar, say for part C.
All right, warm up is done. What comes next, Math Dad?
Screen number 2. Oops, I can do this.
Are you unlocking it for them?
I'm unlocking it and then restricting it. No, I can do this.
You can do it, Math Dad. Science Puppy believes in you.
All right, only took me like 5 tries, but okay, screens 2 through 4 here. So the question is, how much is shaded? But we don't have one color. I count 3 colors there. So out of purple, what fraction is shaded? Out of teal, what fraction is shaded? And yellow. Is teal a real color, Science Mom, or are they making that up?
That looks kind of like an aqua green color to me. But sure, we can call it teal.
All right.
Teal is a color, but usually
teal
it's more blue, usually.
Okay, so it's not one I use very often. My box of crayons only had like 8 crayons in it, and teal was not one of them. But
so this one looks trickier to me, Math Dad. I'm not quite sure what to do because the pieces are not evenly cut up.
well,
But
they kind of are. And actually, Science Mom, before you even try, we're going to give them 60 seconds at least to work on this. And if you can manage to get this screen, go ahead and try the next one.
Yep, so work on this screen on your own and then try the next one and the one after that if you have time. Oh, puppy, you don't need to growl. No growling. Someone just walked by the door. We're in a little office co-op in SoCal and it's like, there are strangers about. Good job, Atharv Gupta, Normand Academy, Isaac, Olivia, and Bella. I'm seeing lots of great progress as you work through these.
I'm actually pretty impressed at how many got it right. And hey, what'd you think of the music on the countdown? I picked that music myself.
Ooh,
That's even better than no music.
I didn't hear any music, Math Dad.
Okay, we don't hear it on our end, but there was music. Trust me, Science Mom. All right, let us know. There were 3 different answers here. What did you get for the purple percentage, or the teal percentage, or the yellow percentage here?
Can I show you what I was thinking, Math Dad?
Yeah, what are you thinking, Science
I
Mom?
was thinking this is a lot easier if I imagine rearranging these colors. If I slide these ones down, then everything up here will be yellow, and then I have 1/4 that's purple and 1/4 that's green and half yellow.
Oh, Science Mom, I like that a lot. And looks like Gamer Boy liked my music, so that's a win for me and a win for you. Now, you've told me fractions. How are you going to get percentages out of those?
Ooh, so 1/2 is the same as 50 over 100. So for my yellow, I'm going to write 50%.
Okay.
And then for the teal, 25 over 100 is the same as 1/4.
Okay.
So now I'm going to check my work, and
ooh.
Yep, there we go. Oh, they did a different way, rearranging.
Yeah, it's up to 25%, 25%, and 50%. That is correct. And I saw some really good strategies. I'm going to come back here and erase what you wrote, Science Mom, just because I wanted to point out the strategy I saw suggested in the chat about so mentally rearranging, or maybe drawing a line right here, because then there are 8 congruent rectangles. So the yellow, I see 4 out of 8, 2 out of 8, and also 2 out of 8 for the other colors. And then those fractions are the exact same fractions you came up with, and I'm sure there were other good strategies. All right, let's see about the next screen. So this one was a little different because the numbers were given to us instead of us coming up with the numbers, and we have to actually come up with that picture.
Ooh, it's the reverse. Okay. So I have 25% purple, and I can color any part of that I want. I just need to color 1/4.
That's correct. 25% needs to end up purple. Go ahead, make it so, Science Mom.
So I have 5 by 4, which means there are 20 squares in total. You know what, Math Dad? I have to be honest. I'm feeling just a little bit intimidated. Am I going to be able to figure this out? Well, there are 4 rows, and if I just do one of the rows, then that's 1/4, right? That's 1 part out of 4.
That's correct. 1/4 are purple.
But now for the teal, I have to do 30%. That's the same as 3 out of 10.
Mm-hmm. But unfortunately, looks like there are 15 left.
Yeah. Oh boy, help me out in the chat. What should I do?
So how can Science Mom figure out how to get 30% of the big square shaded? Because I agree, 25% was somehow easier because that was 1/4, and there was 1 row out of 4. So what strategy did you use to come up with your picture?
Rosalie has an excellent hint for me. Rosalie says 3 out of 10, 3 over 10, that fraction is the same as 6 over 20. And how many squares do I have?
Yeah.
1, 2, 3, 4, 5. I have 20 squares in total, remember? Because I'm not only considering these white ones, I'm considering the whole entire thing. So
Excellent.
I just need to do 6.
Good suggestion, Rosalie. All right. And then, kind of by a process of elimination, I bet you can figure out how to color the rest of it.
Well, I could just say, aha, everything that's left is yellow, but it would be nice if I could relate this number of squares to the 45%. So I had 20 squares in total, right?
Mm-hmm.
And 6, 7, 8. I just did 8 of them. So is 8 over 20 the same as...
You did 9 of them.
Oh,
and
I did 9.
9 over 20 is 45%, or 45 over 100.
Excellent.
So I've got to give a shout out to Gamer Boy for pointing out that this divide by 5 trick is what they mentioned.
Ooh.
So if you had 100 and you're dividing into 20 equal pieces, because that's how many little rectangles we had, well, 100 divided by 20 is 5. Each of the little squares accounted for 5%.
Oh, that's brilliant.
Or it's kind of like working with nickels out of $1.
Yeah.
So that way, it sounds like Gamer Boy thought of it, well, if I need 45%, well, that's 9 5s, so I'd better color in 9 squares.
Oh, I like that strategy. That's great.
Yes, excellent. All right, and I'd love to be able to talk about more strategies, but from the class, but we're going to look at two strategies here. Tiam's strategy and Ramon's strategy. So Tiam is basically following in Gamer Boy's footsteps and said, wait a minute, each little square should be 5%. Those are like the nickels out of our dollar. Whereas Ramon turned it into a calculation. So he said, well, if we get 20 total boxes and 30% are teal, so he took, to make 30% of 20, you just multiply 0.3 by 20 and you get 6. So he actually just turned it into a calculation. Now, when you look at that, weigh in please in the chat. Which strategy is the best? So think about it, and then I'm going to ask Science Mom to weigh in on which strategy she thinks was the best. This is harder than it looks sometimes, isn't it, Science Mom?
Yeah. Well, I have to say, I like the visual strategy, but if the numbers were a lot bigger, it would be too hard to do a visual strategy. So multiplying the percent by the number of total boxes, that would be better. You know, what if I had 50,000 boxes? I can't draw out a square in just a few minutes that has 50,000 units.
That's right. Okay, so perfect answer, Science Mom. I didn't think you were going to get so deep all at once. Most of the people in the chat said they like Tiam's strategy, and you know what? Tiam's strategy is the most beautiful for this particular question. It's great. You could not have done a better solution than Tiam's strategy. But there's something nice about Ramon's strategy. So it generalizes. So if we had asked for 42.7% instead of 45%, boy, Tiam would have been, I don't know how to chop this up. But Ramon would have just said, oh, that's just another calculation, and might have been able to crunch those numbers a little more easily than the rest of us. So which strategy is the best? Well, they're both great strategies. Tiam's was the most beautiful and for this particular question, but Ramon's strategy is the best maybe if they're going to be asking variations on the question.
Michael's MA says that Ramon's is faster and more mathematical. And I think it is, but they're both good strategies, but this one definitely is faster and it scales. You can do it for bigger problems.
That's right. You can answer a much wider variety of questions. And when you get onto algebra, you're going to be trying to solve huge varieties of questions and mysteries along the way. So, but I like both strategies and both skills, and so it's pretty cool if you could do it either way.
All right. Math Dad, guess who fell asleep?
Oh, no, his eyes popped open. Yeah, but he's just loving being cradled there. Yeah, this Kaladin is a good dog. All right, we are moving on to the next two screens now, Science Mom, and this is going to be kind of cool. So we're actually just going to do this one together right now with the help of the chat. So what percentage of the square is shaded purple? And so let's quickly count. So how many rows and how many columns? I count 1, 2, 3, 4, 5 rows and 5 columns. So this one's a little different than the previous picture, even though it looks almost the same. So help me out. How
can I figure this out with percentages?
Yeah. So yeah, what's the answer? But yeah, how would we even think about it in the first place?
So I have 25 units in total. That means that my little mathematical trick that the chat mentioned last time is that if I times each of those blocks by 4, that will give me the percent, right? So for example, if I had, am I making this more complicated than it needs to be? If I had this block over here and I said, okay, I have 1, 2, 3, 4 yellow blocks, can I times that by 4 and say that's 16%?
You can indeed. So yeah, Rosalie was hitting it up on the purple. So Rosalie said, yeah, it ends up being 36%. And Rosalie just made it a fraction. Said, well, there are 9 purples out of 25.
Oh, I like it.
So 9 out of 25, that fraction is the same as 36 over 100. And yeah, so you could multiply both the numerator and the denominator by 4. Or, so at Gamer Boy or Tiam on the previous screen would have done what you were doing, Science Mom, would have labeled each little individual square with a 4%. And And then you're right, we can count the squares and come up with 4%. All right, so help me out. Science Mom got yellow and Rosalie got purple, but what about teal?
We have 12 squares in total for teal.
Okay, so what did we say to do once we knew the number of squares?
Times, multiply by 4.
Okay, so 12 times 4, and Rosalie has it again, 48%. So 12 over 25 is the same as 48 over 100. And then if we've done things right, those three numbers should add up to 100%.
Ooh, nice.
And
it worked.
We did it. Yep, it's nice to have the answer checker there. In real life, when we answer a question, we don't immediately get to see the answer right afterwards. But
not always, nope.
No, one of these days we'll get that upgrade. That's like a stat screen next to us showing us whether we got it right or not. Okay, so that was pretty cool and kind of an interesting pattern there. I don't know how they came up with that pattern, but I know we do have some artistic students. So on the next screen, you'll see a button that says Make My Challenge. And this is your chance to make a challenge problem for the other students. And you can just dive right in, although I can also try here with... So you can decide how you want it divided up, how many pieces, vertically or horizontally. And then once you have that picked, you can pick a color and start painting by clicking on the individual squares. Then once you're done, you have to answer the question, what percentage of each color do you have? And then you can post it for your classmates to solve. And we are going to spend the next 10 minutes of class making our own problem and then solving problems from our classmates. So we're building challenges. So what cool art can you come up with? And can you actually solve lots of challenging problems? And knowing this group like I do, I suspect that people are going to come up with some tricky patterns. So I'll wish you good luck and say attack.
Excellent.
And we'll be back in a few minutes to comment.
This was so fun. Math Dad, I have to give a special shout out to Sakina and Liza, who made a face and a hi. I thought those two were fun. So those were the two that I did.
Those were pretty clever. Those were the ones that made Science Mom laugh out loud.
Yes. But I love all the different patterns and their different sizes.
Yeah, different shapes, a lot of variety. Definitely some really tricky ones. People were not going easy on this one.
But I have to say, after doing a couple of them, I came up with a strategy that I really liked.
Ooh, and what is that, Science Mom?
So I would count how many blocks there were in total. This one is 5 by 5.
Okay.
And then I would say, okay, there are 25 blocks in total. What do I need to multiply 25 by to get to 100?
So 4.
4. And then I had my secret number, and I could just count, okay, how many green blocks? 1, 2, 3, 4, 5, 6. And then 6 times 4 is 24.
So you're saying each of those little blocks is 4%.
Exactly.
So you could just count the blocks and multiply by 4%?
Yeah.
Yeah.
And I have to give a quick shout out to Rosalie, Emrea, Arushi, and Joseph because they completed the most other student challenges.
And then Michael as well. Yes.
Yeah, and Cora, great work. Good job, Arthur and Oliver. And this is something you can come back to, too. You can do all of the challenges. You don't need to stop just because we're moving on to the next part in class.
That's right. And next, if I had a longer timer, I would have had you do it even longer just because, yeah, this is good and it's good practice. And in some sense, chopping it into 25 equal pieces was actually, I think that made it easier than if it had been maybe a smaller number. What if I had done just like 9 pieces? I don't even know if that was an option in the drag controls.
What if you do a number where you can't times it by a whole number to get to 100?
That's right. So decimals do get a little bit trickier. What if it was 3 by 3? If there were just 9 squares total?
We would have to involve decimals to get to 100, right?
Yeah, that's right. So each square would be 1/9. So what fraction would 1/9? Oh, sorry. 1/9 is the fraction 1/9. What percentage is 1/9?
Ooh, that's a good question. Type it in the chat if you're watching live, or if you're watching the recording, pause for a minute and think. What fraction is 1/9? What percent is 1/9?
So Rosalie said that 9 wasn't an option, that it didn't let us do the threes. I didn't pay attention when we were choosing there. But yeah, 1/9. How would you come up with that fraction? And Betty really wants you to take a look at hers.
Oh no, I just lost my count. 1, 2, 3, 4, 5, 6, 11 times 4 is 44. I'm going to check my work real fast, and then I will go to Betty's, and then we will answer the 1/9 question.
All right, so Rosalie says it's going to be 11.11111111111%
Going on and on.
Yeah.
So then, do you just round?
Yeah. Typically, that's all you can do, or you can leave it as a fraction. But yeah. Once the decimals get so far out, it's such a tiny portion that we usually don't care so much about it. But yeah, it is nice when percentages work out to be nice round numbers. But
definitely. All right, do we have time for me to do one more?
Do one more here. Let's see if you can get Betty's challenge.
All right, so first I'm going to look how many squares do we have. It's a little hard to see, but I'm thinking there's 1, 2, 3, 4 across the top.
Oh, I was thinking of just 2 rectangles across the top.
Oh, maybe it's just 2. You know what?
Yeah.
Either way, I can.
Yeah. Oh, that's interesting that you could chop it up different ways.
Oh. So I'm going to say we have 2 rows across the top and 4 rows across the bottom.
So 2 columns, 4 rows.
Yes. Thank you. Thank you for correcting that, Math Dad.
Oh, no, Science Mom.
It is hard to write and talk at the same time.
That's okay. You're trying hard. We all understand. All right. So altogether, I'm counting, looks like
so
8
that's
rectangles.
8 rectangles in total.
But 8 doesn't go into 100 evenly.
It does not.
So how many times does 8 go into 100? Well, it goes in 12 times to 96, but 13/8 would be 104, so it'll go 12.5 times.
So can I use 12.5 as my magic number?
You can, and in all honesty, you have to. That is the percentage.
All right, I'm writing
for each of those little blocks.
12.5 up here. That's my magic number. So now, for the purple, for example, I can just count how many purple blocks do I have. I I have 3.
3
So,
purple blocks.
3 multiplied by 12.5, excuse the sloppy handwriting.
And actually, why don't you type it in the box just like that? 3 times 12.5.
3 times 12.5 is 37.5.
Good.
And then with the teal, I'm going to do the same thing. 2 multiplied by 12.5 gives me 25%. And then yellow, I have 3 again. 3 multiplied by 12.5 is 37.5%. I'm going to check my work. And we're going to find out if I managed to pass Betty's problem, a most excellent problem, I will say.
It was. So it looked like it would be easier than the others, but Betty was sneaky on us and picked some total number of rectangles that didn't go evenly into 100. So good question there.
This was great. I liked this
Betty.
one a lot.
All right. So I'm going to jump over to screen number 7 now. On screen number 7, we are asked to describe the strategy. So you've done it yourself several times. You've seen Science Mom try it. So how would you figure out 20% of 40? And I'll say there are lots of ways of doing it, although perhaps a visual explanation would suit some of you. So you could use the grid off to the left, or if you want to try to do it in words, you can use that box. Take a couple of minutes and see if you can put into words how you would calculate 20% of 40, and then we'll highlight some solutions.
I'm putting a smiley face right there just for encouragement. You got this. Go team.
They never could have done it without you, Science Mom, but now.
I'm here for the moral support, as is Science Puppy. Science Puppy says, go forth and conquer the math.
I think you looked a little groggy as you pulled him up there.
Oh, sorry, Puppy. You were pretty soundly asleep. We're seeing some great work. Just keep on working on this for another minute or so. Good boy, good boy. We have a request for music, Math Dad. Do we have any background music?
But it's all in 3 minutes or 4 minutes or 5 minute chunks. I've got to break down my music into shorter chunks.
Definitely. You need shorter music timers. How much more time until we discuss? Another 20 seconds?
Another 20 seconds, and then we're ready.
And if you're watching the recording and you want more time, you can always pause the video. All right, are we ready?
I think we are ready. Okay.
Good boy, puppy, good boy.
So I am going to attempt to share a few solutions here. So the names didn't come with, unfortunately. Arushi was one of them. Cora was one of them. Sorry, I lost the names. But let's talk about these strategies. So the top two were very similar strategies. So we want 20% of 40. Well, 20% means the same as 20 over 100.
Ooh, I like it.
Or 1/5 is the same fraction. And just multiply that by 40. And if we multiply a fraction times a number, that means we multiply the numerators, and then we simplify. So 1/5 times 40, or 2/10 times 40, or 2/10 of 40, is 8. So, or 40 divided by 5, those all work out to be the same thing. So divide 40 by 5, good words, And there were some great pictures. This is the only one I selected. It looks to me, Science Mom, like this box has 40 little squares.
Ooh, it does. It's 4 by 10.
Mm-hmm. But then how would we get 20% of 40? Well, 20% means 1 out of every 5.
Ah.
Right? Well, so in this case, so if we divide 40 by 5, we got 8. So we could chunk this into 8 different pieces. And oh, it looks like they weren't even quite finished here of breaking it. So it would have worked out a little easier if instead of doing 4 by 10, if we had done it 8 by 5. Then for this particular question, chopping it up that way might have worked. But yeah,
I like the strategy there, though.
Yeah.
It's off to a good start.
We just needed to break it into 8 equal pieces of 5, or I guess 5 equal pieces of 8 is what we were after.
Mm-hmm.
What was I thinking? So we're well on the way there. Didn't quite finish. All right, it is time to do our last 2 screens. We've got a cool down problem. Science Mom.
Cool down.
All right, so yeah, just what percentage of the square is yellow? And my guess is by this point we might not even need to write anything down. Some of us might even be able to do this in our heads, but yeah, take a minute and see if you can do it.
Ruby says it's locked. Can you unlock it, please?
No, I canceled. Did I not? I did. Okay,
You
sorry,
did.
Ruby. Thank you.
Thank you for letting us know. All right, is it open now?
It's open now. All right. Boy, that's a chat. They're all there. Dad, shame. You've got to unlock it. Yes. All right.
Oh, good. It is open now. Thank you for letting us know about that.
You can count on the chat to let you know about
That's
those
right.
types of things.
They keep you in line, Math Dad.
Yeah, so that's why I keep them around.
So we have 25 squares in total.
There are 25 in total, so everybody take 1 minute and see if you can come up with the percentage of that square that is yellow. And as we've seen, there's not just one strategy that could get us to that answer. And for that matter, there's not even just a best strategy there.
There are multiple strategies. I'm going to go with a fraction-based strategy this time. 10 is out of 25. That's how many I have. And if I want to get it to something over 100, which would be a percent, whoops, then I've got to times both the top and the bottom by 4.
Good. So 4 times 10 is 40.
Yep. Now I'm going to check my work.
40%, says Science Mom. And you could explain, you said it all out loud.
I did.
And it would take just a minute to actually write that all out. But I like this fraction approach. And I personally did it a similar way, except I said, well, there are 5 rows, 2 of them are yellow, so 2/5 will be yellow. And then 2/5 is the same as 40%, also converting the fraction to a percentage. And a lot of people coming up with the same answer. And it seems like most people are using the fraction approach, although some people said, well, each little tiny square is going to be 4%, and it looks like there are 10 little squares. So 10 times the 4% is a total of 40%. So good. So
Good job, everyone. I'm seeing some great answers here.
all right, so how well did you understand the math in this lesson? So do you think you could maybe teach this to someone else? Okay. So are you able to visualize a percentage on a grid? And could you calculate the percentage of a number?
I definitely feel stronger in calculating percentages than I did before this lesson.
Good.
So I am happy about this. Visualizing a percentage on a grid, I'd say I'm a little bit more here with that. I could use some more practice.
Okay.
But overall, I'm going to pick one of these.
All right, and then how did you feel about learning math?
I love learning math with Science Puppy and all of our friends in the chat. So even if I'm a little unsure about the concept, I think I'm always going to feel this way just because it's great.
Got a pretty good group here. So this has been us practicing. We're going to be teaching a couple math classes this fall in a very similar format, and we want to make sure that we are up and ready to go. And I know all of you are starting school pretty soon, so got to sharpen the saw, get ready, because sometimes we forget a lot in the summer, and we definitely want to be at our best when school comes around.
That's right. And let me give just a quick little bit of advice. If you're looking at this lesson and thinking, boy, I am just not sure how to visualize a percentage on a grid, or I don't know if I can calculate percents, the great thing about this lesson is that it's recorded and you can go back through and practice again. And practice really does make permanence. It helps concepts stick.
That's right. So until next time, work hard, grow smart, and we'll see you in our next lesson. Tomorrow we'll be talking about the distributive law.